So today we're looking at a conservation momentum experiment, but the big thing is going to be the angular momentum. But first, let's do a review of the conservation momentum. I've got two pucks here, and they're both the same mass. One's going to be at rest, one's going to come in and hit head-on with the other one. First predict, is this an elastic or inelastic collision, and what do you think would happen? So make your predictions, and here we go. Okay, so one at rest, one moving in. So you notice for the most part, one stopped and the other one left. And the other one leaves pretty much at the same speed. Because when you have an mv of momentum coming in, you have to have an mv leaving. So is this an elastic or an inelastic collision? Well, if this goes away at the same speed, that would be an example of an elastic collision because we keep the same kinetic energy. Okay? What would happen if we hit a little off-center? What would be different about hitting things not exactly head-on? What would be different? So you may have noticed we have an MV coming in. We actually have to have an MV leaving. We absolutely have to. So what happens, one goes in one direction, one goes in the other direction. So we have two vector amounts of momentum, one going this way, one going this way. So if we add those two vectors together, this vector plus this vector, you actually end up with a vector going right down the middle, which also is an MV. Has to be. That's the law of conservation of momentum. But the interesting part is when I make this an inelastic collision when these stick. So in a moment, I'm going to put some Velcro around there and repeat the exact same experiment, and we'll see what exactly happens. Boss?